Hello and welcome to another video on solving simultaneous equations using the elimination method. Now in the previous few videos we've just looked at whether we add or subtract the equations in order to eliminate one of the variables, and we came up with the saying, so if we have the same signs we subtract the equations, if we have different signs we add the equations. Now in this video we're going to look at what happens if we don't have the same number in front of our variables. Okay, so remember, we're always trying to eliminate one of the variables. So in this case, we're going to have to do a bit of manipulation first in order to make sure that we have the same number in front of one of our variables. So if I go through this example here, I'm going to look at trying to eliminate the b's. Now, I've got b here, so this is just one b, and I've got four b's here. So in order to have the same number of b's, what can I do? Well, I can multiply this whole equation, this top equation, by 4. So if I multiply this whole equation by 4, well, that's going to give me 4b's. So let's do that. So if I multiply the left-hand side by 4, I'm obviously going to have to multiply the right-hand side by 4. But that's okay, as long as I'm doing the same to both sides. So let's do that. So if we multiply the left-hand side by 4, 6a times 4, well, that gives me 24a. And now b times 4, well, that would be plus 4b. And notice how we've got 4b and 4b now. And now if I multiply the right-hand side by 4, 9 times 4 is 36. So now I've just changed the top equation. It's still exactly the same because I've done exactly the same to both sides. So I multiply the left-hand side by 4 to give me this. And I multiply the right-hand side by 4 to give me this. So now if I just copy down this bottom equation underneath, and now you can see that we have the same number of b's, we can eliminate them. So are we going to add or subtract the equations? Well, we have the same signs in front of our b's, and remember the same sign means subtract. So I'm going to subtract this bottom equation from the top equation. So we've got 24a subtract 5a, well that gives us 19a. The b's will obviously cancel out. And on the right hand side, 36 subtract 17 is 19. So now we've got 19a equals 19, therefore a is equal to 1. And now we can substitute this back into one of our equations. It doesn't matter which one we choose. We could choose the top one, we could choose the second one, or we could even choose this one here. So any one of these will always give us the same answer. So let's choose the top equation. So we've got 6a, well, we know a is 1, so that's going to be 6 times 1, which is 6. And then plus b, and that is equal to 9. So we can just subtract 6 from both sides, and we're left with b is equal to 3. So our solutions are a equals 1 and b equals 3. So just remember, if you have different numbers of one of the variables, you're going to have to do a bit of manipulation first before you add or subtract the equations together. And in this case, I multiplied the top equation by 4 so that I had the same number of b's. Okay, I've got 3 more examples to go through, but as always, I would encourage you to pause the video and see if you can solve these simultaneous equations yourself first. Okay, so let's look at the first one here. Now, what I'm going to do is I'm going to equate the a's. So I'm going to get the same number of a's. And the reason I'm doing that is because I can do that quite simply. I can just multiply this top equation by 4. So I'm going to multiply this whole equation by 4. I'm going to multiply the left-hand side by 4 and the right-hand side by 4. So let's do that. So on the left-hand side, 2a times 4 is 8a. And you can see now that we're going to have the same number of a's. And then plus 8b. And now if we multiply the right hand side by 4, we're left with 48. And now if we just copy down the second equation. And now the thing to think about is whether we add or subtract the equations. And with our a's, we have the same sign, so we are going to subtract. So 8a subtract 8a, well that just cancels. 8b subtract 5b is 3b. And 48 subtract 42 is 6. So 3b equals 6, therefore b equals 2. Now let's find the value of a. I'm going to substitute it in to the top equation. So we've got 2a plus 2b. Well, we know b is 2, so 2 times 2 is 4. And that equals 12. Now into question 2, I'm going to make the b's the same. And the reason I'm making the b's the same this time instead of the a's is because all I need to do is multiply this top equation by 3. And that will also give me 6b. So if we multiply the top equation by 3, I'm left with 15a plus 6b. And that equals 21 times 3 is 63. And now if I copy down my second equation, and again with my b's I've got the same sign, so I'm going to subtract. So 15a subtract 4a, that gives me 11a. These b terms will cancel out with one another. And on the right hand side, 63 minus 30 is 33. So 11a equals 33, therefore a is equal to 3. And now let's substitute that back in. Let's choose the bottom equation this time. So we've got 4a and a is 3, so 4 times 3 is 12. So it's going to be 12 plus 6b equals 30. So if I subtract 12 from both sides, I'm left with 6b is equal to 18. Therefore, b is equal to 3. So my solutions this time are a equals 3 and b equals 3. And finally, the last pair of equations. So this time, I'm going to multiply the top equation by 2. And the reason I'm doing that is because that gives me minus 4x in the top equation and 4x in the bottom equation. It doesn't matter that one of them is negative. As long as we've got the same number in front of one of our variables, that's absolutely fine. We can eliminate it. So if we multiply the top equation by 2, what are we left with? Well, negative 2x times 2 is negative 4x. 6y times 2 is plus 12y. And on the right hand side, 24 times 2 is 48. So now I can just copy down this second equation. But this time, because we have different signs in front of the variables that we want to get rid of, we are going to add the equations together. So we are going to add these two equations together. So negative 4x plus 4x is 0, so they cancel out, which is what we want. 12y plus 4y is 16y, and 48 plus 32 is 80. So we're left with 16y equals 80. So now if we divide both sides by 16, we get y is equal to 5. So now we've got our value for y. I'm going to use the bottom equation just because we don't have any negatives. It always makes things a lot easier if you don't have negatives. So the bottom equation, we have 4x plus 4y. Now y is 5, so 4 times 5 is 20, and that equals 32. Now, if we subtract 20 from both sides, we're left with 4x is equal to 12. So now all we're left with is x is equal to 3. So this time our solutions are y equals 5 and x equals 3. So just to summarise, whenever we're trying to eliminate one of the variables from our equations, we're always trying to make the number in front of that variable the same so that we can get rid of it. Okay, now in all of these examples that I've gone through in this video, we could do that by just multiplying one of the equations by some number. Now that won't always work. Sometimes you'll have to multiply both equations, and that's what we're going to look at in the next video. So thanks for watching, and hopefully I will see you then. Take care.